Hi everyone, welcome back to SE301. Today we're doing lesson 14, trade space analysis. Just as a reminder of where we are in the course, this is the last lesson in the decision-making phase. After this we move on to solution implementation. So well on our way to almost being complete with SE301. So some lesson objectives for the day. We have got 4 of them. Understanding the concept of a trade space, applying analytical techniques to develop improved candidate solutions, understanding and calculating initial and final value gaps, and then understanding the role of systems thinking in trade space analysis. In this last lesson objective, understanding the role of systems thinking will kind of be strung throughout the entire lesson. We'll really analyze how we can find the optimal solution within the trade space. So just as a bit of a refresher of where we are in decision-making phase, we've done value scoring and costing, we've looked at sensitivity and risk analysis, and now we're focusing on improvements in trade-off analysis. The big takeaway for this lesson is understanding that this is a value-focused thinking approach. Just like everything that we've done in this course, we focus values first before alternatives. Our alternatives are driven by the values that our stakeholders desire. So understanding what the trade-off or the trade space is important. And what is the trade space? Well, the trade space is all the range of feasible outcomes, if you will. If you think about the genesis of where we came from and the progression of identifying what the problem was in the initial problem statement, going through problem definition, stakeholder analysis to come up with a refined problem statement, developing fundamental objectives, functional hierarchies, creating an additive value model, building a feasibility screening matrix. All that work that went into this process was calling down all of the non-important alternatives or all the things that didn't matter to us and coming out with the few solutions that our stakeholders would find the value that they need in. And those few solutions, those feasible solutions, are what we define or what we call the trade space. So graphical representation of our trade space can be seen here. We've got Phoenix. This is the house buying problem from last lesson, where I'm picking a house that I want to buy based on 4 value measures. But my trade space is all these alternatives: Phoenix, Salt Lake, Las Vegas, San Diego, according to these value measures. This is all the space that I have to work with. Within this space is my optimal solution. And the key here is to find what that optimal solution is, and oftentimes it is not going to be one of these bars. It's not going to be an alternative that we've previously defined. It's going to be an alternative that we need to improve. So one of the first first things to identify is that our ideal is rarely ever reached. This case here, we're getting pretty close to the ideal, just the way that this problem is working out. One of our locations is close, or one of our houses is close to the ideal, but in most cases, the stakeholder ideal is typically not reached. If we had a solution that was extremely close to the ideal, then it'd be easy to make a decision, but sometimes it's harder to distinguish between alternatives. They're very close to each other in value. Specifically for individual values, if you just take a look at this chart here, if I look at the greens, for instance, I can see a lot of my solutions, particularly Salt Lake, San Diego, and Baseline, have really good schools ratings, and they're close to the ideal. So within this trade space, we need to narrow down our options and improve those that are close to the ideal so that we can better distinguish what the winning solution will be. And again, value-focused thinking identifies what might be possible. So I kind of answered these questions, why we show the ideal, just to show what the optimal solution is for the stakeholder, and also to try to get to that optimal solution. So we're going to use this chart here, to create better alternatives. The way that we're going to do that is by focusing in on value gaps. I'm just going to build this slide out all the way. So let's take Salt Lake, which is our highest alternative right now. Achieves a value of 93. Ideal is 100, of course. So our value gap is, assuming that we picked Salt Lake as our winning solution, that's what we told our stakeholder that we believe they should decide on. The value gap is the difference between that and the ideal. So in our case here, with the Salt Lake having a value of 93, the value gap would be 7. From there, we look at how we can minimize this value gap of 7. I'm going to try to improve this solution of Salt Lake to a point where it gets as close as possible to 100. So I'm going to look at the largest value measure gap. And what I mean by value measure gap is that value measure that's as far away from the ideal as the others. So schools rating is the lower, in terms of, in this stacked bar chart, schools rating does not achieve the ideal as well as the other value measures achieve the ideal. So we're going to try to target schools rating to make this alternative even better. This stack bar chart right here for San Diego shows the largest value measure gap for all solutions. You might think, well, what's the point of looking at San Diego if we know that San Diego is only a score of 53 compared to 93? That's true. We might not want to waste our time with San Diego because it achieves such less of value than Salt Lake. However, in many cases, you could look at these other solutions that don't quite achieve the highest value, but with a little bit of improvement of alternatives, they could achieve a high value. So maybe we can look at Las Vegas, for instance. Just think of it this way. It's very hard to improve the schools rating for a solution, but it's a lot easier to improve square footage and number of baths. I just throw money at my problem, and with some time I can build an add-on to my house, and before you know it, I've got an extra bath and a couple hundred extra square feet. That would of course increase the cost, but it's a way to improve a solution. And by doing those measures, I might actually create a different winning solution. So it's important, and it kind of goes back to our discussion, or to our injection about systems thinking. It's important to understand all the environmental factors at play in each of your alternatives, and to really approach this the problem as a systems thinker would, with the correct understanding of perspectives, so that we can improve the solution that we really need to improve and achieve the highest value for our stakeholder. But in this case here, we're going to, for the sake of improvement alternatives, we're going to focus on the Salt Lake alternative. We're going to focus on this value gap, which is currently 7. So here's another representation of this and how we're going to achieve an improved candidate solution. So our initial value gap is 7. We're going to target the value measure that does not reach the ideal, that is as far away from the ideal or is further away from the ideal than other value measures. And we're also, if we were able to, we can't in this case because the number of beds and number of baths is already at the ideal. But if we were able to, we could also try to target those. We're going to just do as much as we can with this alternative to make it as close as possible to the ideal. So the initial value gap is 7. How do we improve the winning solution? I just talked about that. We're going to target those value measures that don't achieve the ideal. And then what is the final value gap? So I guess in reality, how are we going to do this? Well, it will be very hard to improve the school's rating for a school. You could even argue that it's impossible to do quickly. But there are some measures that you could take. Maybe you could hire a tutor for your children, assuming that that's why you care about the school's rating. You could hire a tutor for your children so that they can get that extra attention if needed. Now, of course, that's going to drive up costs a little bit, but it'll also provide you a little bit of extra value that you can push towards your school's rating to increase the overall value that value measure gets. So by doing measures like that, you can decrease the value gap. So I arbitrarily increased my value by 4. Or I said that, well, I have the spreadsheet here, but so my school's rating initially for Salt Lake was at a 75 for the value. You can see that it achieves, let's see, so a school rating of 4. And I said that if I increase a tutor, or if I add a tutor to it, then I would get a score of 4.5, excuse me, so that it falls within 75 and 100. So by changing that school's rating from a 4 to a 4.5, now I know that it's just a discrete function, and technically the school's rating can only be 4 or 5, but I added a little bit of creative liberty in changing these alternatives because I'm kind of thinking outside of the box. I'm not going with a typical schools rating in the sense that it's just the schools. I added some other things to supplement education, which is really what I'm concerned with. That's the real value to the stakeholder. So by doing that, I was able to improve the candidate solution and improve the school's rating value. And now the final value gap, by increasing that, is a 3 as opposed to a 7. So we're getting even closer to the ideal. So that's what our aim is in solution improvement, is getting close enough to the ideal, using the feasible solutions that we have to improve them in a way that will achieve maximum value. The last question here, can we tell which value measure is the most important to our decision maker? Yes, if you just look at the area of each of these value measures, you'll see that square footage is the most important, followed by schools rating, followed by number of beds. But that's why it's important to target on those specific areas. So in the end, what does this look like for our trade space and how it helps us make decisions? What we've done in the last 10 minutes or so is we've refined the trade space. We've made a distinction between the winning solution and the ideal a little bit more clear, and we've also weeded out those alternatives that aren't really going to make it. So we've made the trade space more defined. We've shrunk it a little bit so that our decision makers can make easier decisions. Graphically, what that looks like, we know that the baseline in San Diego are dominated solutions because we have other solutions that have a higher value for a lower cost. So we can remove those from the equation altogether, and we've added the improved solution of Salt Lake Improved, which was by adding or by improving our original candidate solution and adding a tutor, for instance, to increase the school's rating. So now this chart is what we can use as a more refined product to help the stakeholder make a decision. And this shows very clearly that although Phoenix might not be the best decision, or have the best value, it is the least expensive, but Salt Lake has extremely high value for a little bit more money. The one thing that this chart doesn't incorporate is risk, and risk from our last lesson is extremely important in making these decisions. Something that's not on this chart is, okay, well, where do I live right now, and like what's drawing me to these locations? Are there jobs involved? There's other factors at play. It's not just the house and where it is and the cost of the house. There's some other risks involved. So the risk analysis coupled with this cost versus value analysis coupled with trade space analysis, all those things together will help us make a decision, and ultimately will result in a systems engineer saying, stakeholder, I believe that you should do this because of reason A, B, C, and D. And that is really what our stakeholders need. They need this this concrete underlying science behind the decisions that they make. So that is it for this lesson. Hope it was enjoyable, and I was happy to walk you through decision making. Take care.